Okay, Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Shehroz Abdullah and today we are going to discuss what is nuclear fusion. The topic of our discussion is nuclear fusion. Before this lecture we have done with nuclear fission, Fission. Fission was splitting. Now keep it aside. We are coming towards fusion. What is nuclear fusion? The word fusion, F-U-S-I-O-N, fusion means to fuse into one another, to merge into one another. When two lighter nuclei fuses or merges into one another to form a heavier nucleus, this process is known as what? Nuclear fusion. In other words, we can say when two daughter nuclei fuses or merges into one another to give a parent nucleus known as what? Nuclear fission. So we can also define it like that. The process of fusing or merging daughter nuclei to form parent nucleus known as nuclear fusion, or the process of combining lighter nuclei to form a heavier nucleus known as nuclear fusion. And do remember one thing, mass of parent nucleus or heavier nucleus will not be equal to the sum of masses of daughter nuclei. Why? Because this is known as mass defect. This is known as what? Mass defect. When mass of parent nucleus or heavier nucleus is not equal to sum of masses of daughter nuclei, this is phenomena is known as mass defect. Why this happens? Because sum of mass is converted into energy into the environment and that cannot be retraced back. That is why the mass of parent nucleus or heavier nucleus is not equal to sum of masses of daughter nuclei. Now we are going to discuss one best example of this nuclear fusion is proton-proton cycle. You know what happens in proton-proton cycle? Look, this is proton, this is also proton, and it gives you what? It gives you, look, protium and protium combines and gives you deuterium over here. Okay, this gives you what? Deuterium over here and beta also. Now this is the first step. Now what happened? What is happening next? This formed product will this known as deuteron. Deuterium we can say, or deuteron. Deuteron or deuterium we can say, right? This is step number 1. Now coming towards step number 2. This deuteron is combined with hydrogen 1,1. Okay, and it gives you an isotope of helium-3,2 with release of gamma in form of rays, right? This is gamma rays. Energy is released in form of gamma rays. This is an isotope. H3,2 is an isotope of helium. Now this product form, okay, this product forms again like this, recombines with each other, okay, and it gives you what? It gives you helium and 2 more protons with release of gamma rays. Okay, this is helium, right? Okay, this is proton again, proton or protium we have formed, and gamma rays in form of energy is lost over here. So this 3 steps is followed by proton-proton cycle. These 3 steps is known as what? Proton-proton cycle. So in today's lecture, this was all about today's lecture. Let me summarize today's work. In today's lecture, we have discussed about nuclear fusion. Nuclear fusion is that process in which lighter nuclei combines and gives a heavier nucleus, okay, or we can say daughter nuclei combines and it gives you heavier, parent nucleus, right? This is known as nuclear fusion. Mass of parent nucleus or heavier nucleus is not equal to sum of masses of daughter nuclei. This is known as mass defect. Why? Because mass is converted into energy in form of into the surrounding that cannot be retraced back. Okay. Now, best example of nuclear fusion is proton-proton cycle. This is protium. This is protium. You can say proton-proton, and it combined it gives you deuteron, or you can say deuterium with beta emission. And this deuteron is then again combines with the proton or protium, gives you the first isotope of helium, and with the release of gamma rays. And this formed product again recombines with each other, and this gives you a helium. And again, proton and proton is reformed, or here energy is released in form of gamma rays. So this was all about today's lecture. Chapter number 18. Chapter number 18. Comprehensive questions or theory is finished today. Chapter number 18. Nuclear physics theory or comprehensive questions is finished today. In the next lecture, we will start with the MCQs, conceptuals, and numericals of this chapter number 18. So you have to read all these topics from book. Reading is always home task, and this is your home task, and you will read the topic which I have taught you in the class today. You will read this topic at home. This is your home task, right? And in next lecture, we will do with conceptual MCQs and numerical of chapter number 18, nuclear physics. Hope you have understand the lecture. Hope you have enjoyed it. Thanks for watching. Allah Hafiz.